Mechanical system. First we will see the mechanical translation system. So in mechanical translation system, there's input is force, output is linear displacement or linear velocity. Or linear velocity. So there is a three types of elements in mechanical translation system. First one is the mass, second one is damper, and third one is spring. So first we will see the mass element. So in mass element we can make a diagram here for the mass. So there is a mass and force is acting towards the right hand side, and also displacement and velocity is present here. So we will find out the two conditions of mass equation, force equation. A part will be the force expression in terms of the velocity, and in the B part we can present force in terms of displacement. So this is about the force equation of mass element. Now we'll see the damper element. So there is a damper force will be act, and damper is represented by B, coefficient B or small f. So again there is a two displacement x2 and velocity v2. Similarly here also x1 and v1. So there is a relative velocity v1 minus v2 and relative displacement will be x1 minus x2. Now we can represent the force equation in terms of the velocity. F is equal to small f v1 minus v2, or we can represent like f into v, where v is the velocity difference between v1 and v2. Similarly we can find out the force equation in terms of displacement. Again small f dy dt x1 minus x2, or we can write directly f dx by dt. So this is the force equation of the damper element. Now we will see the spring element. So now we'll make a diagram here. One is spring, So a spring constant is K and force is acting towards right hand side, left to right force. So first we will write down A part will be the force equation in terms of velocity. So F is equal to spring constant K integration V1 minus V2 into dt, or we can write directly K integration of V dt. In next part we can write equation in terms of displacement F is equal to K x1 minus x2. So this is the spring force equation. So we can see here mass, damper and spring, and all equations are given here. In terms of mass, F is equal to m dv by dt in terms of velocity. In damper element, in terms of velocity, F is equal to small f into v. Small f is the damper coefficient, and in spring, F is equal to K integration of v dt. Thank you.